Previously, I was trying to salvage some 18650 cells from water damage e-bike battery. There were a total of 91 cells from the battery pack, and I was able to salvage 55 good cells, as you can see in this box here. And what I have left here are the supposedly bad cells on the left side here. They have really low voltage or no voltage at all. Some of them even have reverse voltage, and most of them are under 1 volts. So in this video I'll try to salvage these as many as I can, and I'll also test them afterwards to see how much capacity they still have, and that's if I can salvage any of them. So let's get started. So here are the supposedly bad cells, and there are a total of 31 cells in here. There are also a few other bad cells, but they are beyond repairs. But I have 31 bad cells here. These are mostly have very low voltage or under 1 volt. So here I have 2 stacks. The one on the top, these are the ones that are in better condition. They're less affected by the corrosion. The one on the bottom here are very corroded. Next step, I'm gonna clean up the terminals with my Dremel tools. Right, so I have them all cleaned up. They're all nice and clean now. But I also found out that there are 2 more cells that are damaged beyond repair. See there's a gaping hole on the top of the battery. So I can't use these anymore. So now I'm down to total of 29 cells in here. I also wrote down the initial voltage, like this one here, 0.06 volts. This one here is 0.55 volts. So they all started with different voltages. And I've got 7 corroded cells, and also wrote down the voltage, and also the C mean corroded. Let's double check the voltage of cells. 0.08, 0.54, 0.07, 0.05, 0.06, 0.1, 0.55. It's all accurate. Right, so over here I have 3 chargers. These 2 are combination charger, and they can charge nickel metal hydride, nickel cadmium, and lithium ion. Both of these. This one here is just a lithium ion charger. It can only charge lithium ion battery. So let me show you what happens when I put this cell into this charger. So first up, the Intelli charger i4. Three lights blinking. That means it cannot charge the battery. Now let's put on the lithium ion charger. See what happens. Nothing happened. So this light here is green. That means no battery. But when you put in the battery that is required to charge, it will turn red if it's charging the battery. If it stays green, that means not charging the battery. Let's try the other slot here. Same thing. So here I have a good cells. When I put it in, light will turn red, indicating it's charging the battery. But with a bad cell, just nothing happens. Now let's try it on the Opus charger. This is a very good charger, and it can charge a lower voltage battery like nickel metal hydride, and they are 1.2 volts, right? So show you what happens when I put it in this charger. So it seems to charge. I put it at 500 milliamp. Okay. Now let's wait and see what happens. Okay. So it's charging. Yes, you can see here 1 milliamp. But you can see here it's decreasing the charging rate and fast. Okay. So right now it's 1.7 volts. 3 milliamp hour has been charged. Now it's at about 68 milliamp, and the battery voltage is 1.64. So I think what's happening is that this charger is thinking the battery, because of the lower voltage, is thinking that the battery is either nickel metal hydride or nickel cadmium. So it will charge only up to 1.65 volts. That's it. And that's why you see the charging rate is only 60 something milliamp instead of 500 milliamp. Because those batteries are usually smaller capacity. So for this charger, if I just let the battery sit here for hours, and it will eventually charge up to 1.5, 1.6 volts, and it will stop, and that's it. It's just going to be a waste of time. So what I'm going to do next is I'm going to use a good cell from another laptop battery. This is low discharge cell, and this cell is fully charged. And let's check on the voltage of this cell right now, 4.16, so it's full. And a couple of magnets and a couple of wires, and then I'm gonna do a parallel charging to the dead cell. So let's try it right now. Put this down here. So positive to positive, then negative to negative for about, say, 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it should be good now. And now let's check on the voltage of this battery. 1.9. So let's try this charger first, see what happens. So before it didn't charge, right? All 3 lights blinking. Now it's charging, you see. That means it's charging the battery. Okay, let's take it out. Let's try the voltage. 1.76. Okay, now let's try and see if it works on this charger. You can see it doesn't work on this charger. That's because this charger is a lithium-ion charger only, so it requires a higher voltage. So what I'm gonna do is, for this one, that is, I'm gonna charge it a little bit more, just more parallel charging from a good cell. Maybe another 10-20 seconds. Right, so it's been about 20 seconds. Check on the voltage right now, 2.8. So it's a lot higher now. Let's put on this charger, see what happens. It's charging. So there you go. So it depends on what charger you have. It will be lower voltage on this charger, and for this one you just need a little bit high voltage and it should charge just fine. You know, I did this before and some people say it's too much current. I have this here, and let's see how many amp is going through the battery when I use the parallel charging method. I got my fluke meter measure in amp DC. Now let's pick another bad cell from this stack here. Try the initial voltage, 0.66 volts, just like what I wrote on here. Okay. Now let's do a parallel charging. See how many amp is flowing through the battery. Ready? Started around 4 amp. Now 3. Going down. 2.7 amp. 2.6 amp. 2.5 amp. Right, so hopefully that should be enough. About what, 20 seconds now. So now it's 2.1. So it's keep decreasing the current. 2 amp now. So should be enough. Now let's put it on the charger. Try this one first. It's charging. Now let's try. I'll take this out. Let's try this one here. It's charging. There you go. Now the question is 2 amp too much of a current? Let me show you this. This is the volt charger for the volt power tool battery. And check out the output, DC output, 4 amp DC. So this is a fast charger. It's charging this battery at 4 amp all the time, all day, every day. And I only did the parallel charging for 10-20 seconds. So another question is, what if I use a high discharge cell for a parallel charging method? Is it going to be different? Let's find out. Where is my magnet? Here you go. We're going to do it right now. So let's pick another dead cell from this stack here. Check on the initial voltage. 0.68 volts. Now, positive to positive, negative to negative. Are you ready for an explosion? Five amp started, but it quickly reduced. So it's high. It's higher than the previous charge with the low discharge cell, but not as much. 3 amp now. Still lower than the volt charger, right? 3 amp. So I guess that's where it stays. Okay, so it's been about 15-20 seconds. Let's check on the voltage right now. So definitely faster charger too. 3 volts in just less than 20 seconds. This one took longer. So now at 3 volts, it should be good to charge, right? Let's see. There we go. It's charging. Now let's try my other charger. It's charging just fine. You can see this cell here is capable of putting out between 15 and 20 amp easily. But when I charge with a dead cell, it only gives out 3 amp and it stopped there. And there are no explosion. That's kind of anticlimactic. But I only did it for 10 seconds, right? Who knows? Maybe if I did for 2 hours, it might explode. Now let's check on these cells. See if they retain the voltage. If they don't, then they're really actually dead. So 3.2 volts, that's good. Oops, 2.9, that's not bad. 3.29, that's good. So let's try and put it on my charger here. Let's see what happens. .96, 3.23, 3.32. Alright, all charging at 500 milliamp. You can see this time it does not reduce the charging current. It stays at 500 milliamp. That's because the voltage is high enough. Alright, so it has been about 6 minutes. Let's check on the batteries. See if they're still charging. 500 milliamp. Almost 3.5 volts now, so it's charging just fine. So now I'm going to do the same thing, parallel charging for the rest of what I have here, and I'll show you the result when I'm done with this. So here is an example of a cell with a lower voltage here. So I boosted up the cell and didn't do it long enough. So the cell is still below 2 volts. So the charger still think that the cell is a nickel metal hydride. So it only charged up to 1.5, 1.6 volts. And only a few minutes it says full. Only charged for 9 milliamp hour and it says full. Only 3 minutes. Well, it took 3 minutes to charge a dead cell and it says full at 1.5 volts. So you can go back and forth with a lower voltage like this all day and it's still not gonna be able to revive this cell. As opposed to, you can see these 3 cells, they are happily charging at 3.5 volts now. It's been 15 minutes, so they should be fine and it's charging. This one here already stopped at 3 minutes and it says full. So what I have to do for this cell is just to go back to the parallel charging and boost it up so that will be high enough. I would say preferably about 3 volts, so that the charger will charge it as a lithium ion instead of nickel metal hydride and stop at 1.5 volts. Right, so the testing is done for the first 12 cells. It does take a long time, almost 24 hours. It does take a lot longer to charge and then another 4 hours to discharge. And the results are promising. I was able to revive almost all of them except this one here. It's still working but only gives me 1100 milliamp hour. Almost all of them are over 1700 milliamp hour. But I can see a trend here that any cells that started with lower voltage, like this one here, 0.08 volt, 0.09, 0.1, 0.08 and 0.07, this cell will give me lower capacity around 1700 to 1800 milliamp hour. This one's a little bit higher, but you can see this one here about 1700 milliamp hour. So if the cell started with very low voltage, less than 0.1 volts, the capacity is reduced quite a bit. But if the cell started with higher voltage, like this one here, 0.68 volts, right? You got what, over 1900 milliamp hour. This one here, 2100 milliamp hour. Started at 0.6 volts. Same here for this one. Started at 0.5 volt, only half a volts higher than these cells, but it's more than 10% more capacity compared to the cells that started with lower voltage. So what I learned from this experience is that even this charged cell can still be revived. It depends on how much discharge the cell is. Even at half a volts discharge and been left there for a long time, they still give out almost the same capacity as the manufacturer's spec. But if the cell is discharged too low, lower than 0.1 volts, like this one here, this one, this two, and this one here, you can still revive them, but the capacity is about 10 to 15% less than even if the cell is only half a volts higher. So here are my next 12 cells that I've done with the test. I got 3 corroded cells and 9 non-corroded cells, and they all tested good except this one right here. I got 1350 milliamp hour, but for the most part they all look fine. I was able to save 3 corroded cells and they even give out over 2000 milliamp hour. And I've got 4 other corroded cells that I was not able to save. I couldn't raise the voltage past 2 volts. So these are pretty much dead. So there you have it, all 29 cells. Some are really corroded and I was able to save 25 out of 29. And many of them are even over 2000 milliamp hour. like this one here is 2200 milliamp hour, like this, and this one here. And the most important thing I learned from this test is that if a cell I've got is more than half a volt, in this case 0.6 volts like this here, they still retain their original capacity. And like this one here and this one here, over 2100 milliamp hour, almost 2200 milliamp hour. And if a cell has really low voltage, like this one here, less than 0.1 volts, they are still revivable, but their capacity is a bit less. I would say about 20% less. And finally, if a cell's voltage is very close to zero, between 0.01 and 0.02 volts, like this one here, they are pretty much toast. So I got two very corroded cells. This one is 0.02, this one is 0.01, and they cannot be revived. This one I can revive, but capacity is about 50%, so it's pretty much useless. And that's all for now. My next plan is to pick out the best cells from here, along with the other 55 good cells I salvaged from my previous video to build a new e-bike battery. And until next time, thanks for watching.